ratings of the day. Now we are going to do experiment number 4, whose aim is to implement a Boolean expression using a decoder. But before starting further, we should know what is a decoder. In digital electronics, a binary decoder is a combination logic circuit that converts my binary code information from the encoded inputs to a maximum of 2 raised to the power n unique outputs. Let me suppose if I am having n inputs, I will be getting 2 raised to the power n of outputs. Let me suppose if I am talking about 2:4 decoder, it means that I would be having 2 inputs where n is the number of inputs and 4 outputs. Now, what is a decoder? Decoder converts my binary code into some other codes. It could be a many input to a many output code. Say for example, if we are working with a 3:8 decoder, in the 3:8 I am having 3 inputs and I am going to get 8 multiple outputs, and especially in our experiment we are going to use a 3:8 decoder. Decoders could be active high and active low depending on what conditions we are using it. Let us suppose we are considering an active high case. Let's first of all start with the easy part, 2:4 decoder. In 2:4 decoder, it would be having 2 inputs, I0 and I1, and 4 outputs, Y0, Y1, Y2 and Y3. If the inputs are 0, 0, in that case my output is Y0 is 1, else all others are 0. 0, 1, I am getting output high at Y1. 1, 0, I am getting output high at Y2, else all others are 0. And for 1, 1, we are getting output high at Y3, while else all others are 0. Let me suppose if we are talking about 3:8 decoder. In that case, I would be having 3 inputs and these are my 8 outputs. So now, since we are having 3 inputs, so we are going to make the 8 possible combinations of zeros and ones, and as according to the combinations, I am going to get the output at that particular condition is high, whereas for the other conditions, it will be low. Say for example, for the case of 1, 1, 1, my output is high only at Y8, whereas for the other conditions, it is low. Now let's proceed further with the experiment. Now, explanation of IC 74138. 74138 is a decoder IC, as it is also a 16-pin IC at the multiplexer IC whose IC number was 74153. This is also a 16-pin IC with the IC number as 74138. For our experiment, we are using 3:8 decoder IC. It means that it is a 3 input IC and we are going to get the 8 outputs. As we can see from the figure, that pin number 8 is grounded, pin number 16 is my supply. My 3 inputs are pin number 1, 2 and 3, that is A, B and C, whereas my 8 outputs are Y7 bar, Y0 bar to Y6 bar. These are my outputs. Are we clear with that? 3 inputs and 8 outputs. One more point for this IC is that for pin number 4, 5 and 6, these pins are known as enable inputs. Again, we are looking into enable inputs. Enable inputs again means they are my active inputs, and especially in case of pin number 4 and 5, these are known as my active low pins, whereas pin number 6 is known as my active high pin. In this case, both, since the active low pins, they will be connected to my ground, whereas my pin number 6 is an active high pin, so it will be connected in with the VCC. This should be kept in our mind that we have to connect pin number 4 and 5 both to the ground. It is must for the conditions for the system to work, and pin number 6 will be connected to my supply because it is an active high pin, VCC. Even in this, we could see that enable inputs are G2A bar, G2B and G1, where G2A is my pin number 4, this is pin number 5 and this is pin number 6. 0 indicates active low and 1 indicates active high. Inputs are arranged in the order of CBA, where C is my MSB and A is my LSB. Now let's proceed further. Now we are going to implement a Boolean expression using decoder. Let us suppose we are going to implement y ABC as sigma m 1247, where the decoder output what I want to achieve is y1 plus y2 plus y4 plus y7 bar. But as we could see from the previous thing, that it's not y7, it's y7 bar. It's not y1 or y2, it's y1 bar and y2 bar. So we actually, what we are receiving from the decoder is that y1 bar plus y2 bar plus y4 bar plus y7 bar. So first of all, we need to design a circuit which will convert all these bar terms to my without bar terms. So how to do it? This is the explanation for that. Since we are working with a 16-pin IC where pin number 8 will be connected to my ground and pin number 16 is connected to my supply. Since at these positions 1, 2, 4, 7 my output is high, so for these positions only we are going to use a decoder. Pin number 1, 2, 3 are my input pins. So A, B and C will be connected as A, B and C. Pin number 4, 5 and 6 are my enable pins, out of which 4 and 5 are connected to ground. And pin number 6 is connected to my supply, as these are active low and active high pins respectively. Now 1 and 2. So from y1 bar and y2 bar we are going to take and give it an input to a AND gate IC. Before proceeding further, let us see the IC diagram for an AND gate. This is the IC diagram for an AND gate, which is a 14-pin IC. 7 is connected to ground, 14 is connected to my supply. Since for an AND gate IC or for an OR gate IC or for an AND gate IC, the implementation is somehow the same. The inputs are given to pin number 1 and 2, whereas the output is seen as at pin number 3. Similarly, inputs are given from pin number 4 and 5 and the output is seen at pin number 6. So we are going to implement this circuit in the decoder also. Since y1 and 2 are the outputs, so from 1 and 2 we are going to take it and give it to AND gates. That's why I've written at pin number 1 and pin number 2, and the output is taken at pin number 3. Where the output will be y1 bar and y2 bar. Again we have to look for 4 and 7. So we took one input from the 4 and one input from the 7. Gave it to pin number 4 and pin number 5 of the AND gate IC. The output is seen at pin number 3 and pin number 6. This output is taken as the input to a NAND gate IC. The same implementation as that for a NAND gate IC. 1 and 2 as the input and 3 is taken as the output. So this 3 will be taken as the final output and will be connected to my output pin. From this gate I am getting my output as y1 bar, y2 bar. From this AND gate I am going to get my output as y4 bar and y7 bar. The total output that I am getting at this NAND gate is y1 bar, y2 bar into y2 bar into y4 bar into y7 bar to whole bar, since we are working with the NAND gate IC. Since according to the De Morgan's law, what I am going to get y1 bar, y2 bar whole bar plus y4 bar, y7 bar whole bar. It will be y1 double bar plus y2 double bar plus y4 double bar plus y7 double bar, according to De Morgan's rule. Y1 double bar will be y1 plus y2 plus y4 plus y7. So like this we have received our output back as y1 plus y2 plus y4 plus y7. So this we are going to implement on our circuit using the decoder IC, one AND gate IC and one NAND gate IC.
Hi everyone, so today we are going to discuss the implementation of a Boolean expression using a decoder. So what you have to basically, any Boolean expression will be given to you. Let's take a 3-variable function y of a, b, comma c is equals to summation m1, 2, 4, 7. So these are the min terms which are present in the expression. So we have to implement this expression using a decoder. So how actually we will be implementing? So we will be requiring a decoder IC. So the decoder IC which we will be using is 74138, and the 74138 is active low IC. Now what do you mean by active low IC? Active low IC means that the signals that are 0, that represents a higher state, and the signals which are 1, it represents a lower state in this IC. So according to this expression, summation M1247, what the output should be? Y1 plus Y2 plus Y4 plus Y7. But because this decoder IC is active low, so we will be getting Y1 bar plus Y2 bar plus Y4 bar plus Y7 bar. So first of all, we will be making a circuit which will be changing this active low output to a active high output. So we will be using a AND and NAND combination for converting this active low to active high. So what we will be doing, now one of our inputs is Y1, Y2, so we will be giving Y1 bar and Y2 bar as an input to AND gate IC, which is 7408. Y4 bar and Y7 bar to another AND gate, that is 7408. Okay. Nextly, we will be connecting this to a NAND gate IC. So what will be the output of this NAND gate? Y1 bar dot Y2 bar dot Y4 bar dot Y7 bar ka whole bar. So using De Morgan's theorem, you can simplify it to Y1 plus Y2 plus Y4 plus Y7. So what connections we will be making? We will be taking a AND gate IC and we will be making this circuit. So the first pin of the AND gate will be connected to Y1 bar. Second pin of the AND gate will be connected to Y2 bar. From the third pin, we will be getting the output, which will be what? Y1 bar dot Y2 bar. To the fourth pin of AND gate, we will be connecting Y4 bar. To fifth pin of AND gate, we will be connecting Y7 bar. And from sixth pin, we will be getting Y4 bar dot Y7 bar. Then we will be connecting these two inputs to the NAND gate. Okay, that means third pin of the AND gate will be connected to first pin of NAND gate, and sixth pin of AND gate will be connected to second pin of NAND gate, and from third pin of NAND gate we will be getting the final output. Fine. Now the question arises, from where actually we are giving this input Y1 bar and Y2 bar. So we will be giving this inputs Y1 bar and Y2 bar from this decoder IC. So on the decoder IC we have the 14th pin, which is Y1 bar. So what we will do is we will connect this Y1 bar to the 14th pin of decoder IC. Y2 bar we will be connecting to the 13th pin of the decoder IC. Now Y4 bar is 11th pin, so 11th pin will be connected to Y4 bar, and Y7 bar is 7th pin, so 7th pin will be connected to this Y7 bar. Now what do you mean by that is, first pin of AND gate is connected to 14th pin of the IC of decoder. Similarly, second pin of AND gate is connected to 13th pin of the IC of the decoder, and similarly fourth pin and fifth pins. Now after making these connections, we will be setting the enable signals. So the enable signals for the decoder are G2A, G2B, G1, which are the pin numbers 4, 5 and 6. And to enable this IC, these G2A, G2B, G1 are always set to 0, 0, 1. So that is basically you can ground this 4th and 5th pin because it is 0, and you can connect this G1, that is 6th pin, to VCC. Okay, the pins, these Y0 bar, Y3 bar, Y5 bar, Y6 bar, they will be left as it is because these terms are not present in our expression. Fine. Now we are using a IC 74138, which is a 3:8 decoder. So it will be requiring 3 inputs. Now where actually are these 3 inputs? These 3 inputs are A, B and C, which are pin number 1, 2 and 3. But the main point to be taken care while this is that C is the MSB while giving the input and A is the LSB. So this you should take care of. So after doing this basic concept, now we will be actually making the connections. Okay, fine. So we will be making the connections. So we will be implementing the circuit on this kit, which is the digital trainer kit. So we will be taking 3 ICs for it, which is a decoder IC 74138, AND gate IC 7408 and an AND gate IC 7400. This is the input panel from where we'll be giving the inputs. Okay, and this is the output panel from where we'll be checking the outputs. So now let's start making the connections. Fine. So now from the circuit you can see that the first pin of the AND gate is connected to the 14th pin of the decoder IC. So here I am having a decoder AND gate IC, and here I am having a decoder IC. So the first pin of AND gate is connected to the 14th pin of the decoder IC. So this is 16, 15, 14th pin of the decoder IC. Right? Then is second pin of the AND gate is connected to 13th pin. Second pin of the AND gate is connected to 13th pin of the decoder IC. Right? Next we have fourth, the output which we are getting from the third pin. The output which we are getting from the third pin of the AND gate is connected to first pin of NAND gate. So the output which I am getting from the AND gate is connected to first pin of NAND gate. Okay. Next is fourth pin of the AND gate is connected to 11th pin. Fourth pin. So the fourth pin of this AND gate is connected to 11th pin. So this is 16, 15, 14, 13, 12 and this one is 11. Right? Now next. 7th pin of the AND gate is connected to 7th pin of the decoder IC. Sorry, 5th pin of the, not 7th, it is 5th pin of the AND gate is connected to 7th pin of the decoder IC. So the 5th pin of the AND gate is connected to 7th pin of the decoder IC. Fine. Now see, the 6th pin of the AND gate is connected to the second pin of NAND gate. So 6th pin of the AND gate is connected to second pin of the NAND gate, and from the third pin of the NAND gate we are getting the final output. So I will take this connecting wire and I will be connecting it on the output side. So the third pin of the NAND gate is connected in the output panel. Fine. So after making this circuit, nextly we will be connecting these three inputs A, B and C, which are pin numbers 1, 2 and 3 of the decoder IC. So pin number 1, which is the input A, pin number 2, which is the input B, and pin number 3, which is the input C. But the main thing to be noticed is that CBA means C is the MSB and A is the LSB. Okay. Nextly we have to connect the enable signals 4, 5 and 6, and these enable signals are to be connected to 0, 0 and 1. So 0 means nothing but ground. So what we can do is we can short this 4, 5 pin to 8th pin. Okay. So we will short the 4th, 5th pin of the decoder IC. Short the 4th and 5th pin of the decoder IC, and then you can connect it to ground. So ground is 8th pin, then you will connect it to the 8th pin. Then we will take this one wire and we will connect it to ground. So this is the ground. And now see, our 6th pin, that is G1, is 1. So 1 can be connected to VCC. So our 6th pin is connected to VCC, which is the 16th pin of this IC. And then we will be connecting the VCC supply which is the 5 volts for the 7-4 series ICs. Next, be sure that we are connecting the VCC and ground to the AND gate and to the NAND gate IC also, otherwise our ICs will not work. So the VCC, that is the 14th pin of this AND gate, is connected to VCC of the NAND gate also. and it is shorted with the VCC of the decoder IC. Similarly, we will connect the ground also. Ground is the 7th pin, shorted together for NAN and NAN, and then it is connected with the ground terminal of the decoder IC. Right, so this is the circuit. Now we'll be checking the output. So plug in the supply. So what we have to see at the output is, in the expression we are having the terms 1, 2, 4 and 7. So what we will be seeing in the output is, whenever my input A, B, C, which is basically A is LSB and C is MSB. So that is CBA. That is for 0, 0, 0, 1, 0, 1, 0, 1, 2, 4, 1, 0, 0 and 7, 1, 1, 1. For all these terms, only your output will be 1. For all other terms, that is 0, 3, 5 and 6, the output will be 0. So let's verify it. So for 0, 0, 1, the output is coming out to be 1. Okay, so this light is glowing. This is 0, 0, 1. So output is coming out to be 1. Nextly we have 0, 1, 0. For 0, 1, 0, that is 2. Output is coming out to be 1. Now 0, 0, 0. For 0, 0, 0, output is 0 and 0 is not present in our expression. So the output is coming out to be 0. Similarly, if we take as 0, 1, 1, which is 3. 3 is also not present in our expression, so the output is coming out to be 0. Similarly, we can take the case of 1, 1, 1. 1, 1, 1, that is 7. 7 is present in the expression, so output is coming out to be 1. Okay. So similarly, any expression can be given to you. You just have to make the connections and verify it. Okay, thank you.